Hello again, this is Tim, and in this video I'm going to be going over how to add and subtract fractions that do not have common denominators. So in all the cases here, as you're noticing, each of my problems, the fractions have different denominators. This is by far and away the most difficult part of fractions, or at least one of the more difficult parts. Mostly because there are multiple steps involved, one of which is multiplication. So if your times tables are not at least adequate, that could create some problems for you here. So minor side note, make sure that you're practicing your times tables, you know those at least to an extent. But anywho, a lot of problem comes from the fact that people just don't realize that you, first of all, need to have a common denominator. So a lot of times when I get people first starting out, what they do is they just simply add the tops and then add the bottom. So 2 plus 1 is 3, 3 plus 6 is 9. This is not the answer, unfortunately. Now, the other problem too is that because most of these problems are multiple choice, oftentimes the answer like this would be one of the choices. A lot of times one of the choices or multiple choices are ones that you can come to by making small mistakes like this one. So you always want to be careful when you're doing your math, that you are taking the right steps and doing the right methods to get your answer. Now, I'm going to show you a couple different ways to do this. There is a method that will work for all three of them, regardless of what kind of question you have. I'm going to go over some possible alternatives. In this case here, we'll start off with this one. Again, we need to have the same bottom numbers, the same denominators, common denominators. So we have 2/3 and 1/6. Now, you might notice that one of my denominators, the 3 here, can be multiplied to get to 6. So if that's the case with your fraction problem, if you can multiply one of your denominators to get the other one, you can do that. So I can just multiply this 3 by 2, and that's going to give me an answer of 6. Now, as you may have remembered from previous slides and previous materials that I provided, if you change one part of a fraction, you have to change the other part. So if I multiply this part by 2, I also have to multiply my numerator by 2. So 2 times 2 is going to give me 4. Now 4/6 and 2/3 are what are called proportionate or equivalent fractions. They have the same value despite having different numbers. Just for perspective, and again, you don't really need to know this, but just to give you an idea, 2/3 and 4/6 are equal to 0.6 repeating, so it's 0.666666 going on forever as a decimal. You might often see it rounded off as 0.67. 2/3 and 4/6 is also equivalent to 66.6, again repeating percent. Oftentimes that's rounded off to 66.7%. Again, you don't need to know that for our purposes here. However, it just gives you an idea that 2/3 and 4/6 again are equivalent fractions. You would get that by dividing 2 by 3 and 4 by 6. So if you want to give that a try, divide 2 by 3 and divide 4 by 6 in a calculator, or if you can do it on paper, try that. You should get the same answer either way. Now, anyway, back to our actual problem here. Again, I multiplied both my numerator and denominator by the same number to get my new fraction. This bottom fraction here already has a denominator of 6, so I don't have to do anything with that. I can just bring that over. Okay. And then I can add or subtract, in this case add, as needed. So 4 plus 1 is 5. So my answer to this problem is 5/6. Now moving on to my problem over here, I have a subtraction problem. Again, you will note that my two denominators do not match. Now in this case, I'm going to change the bottom fraction. Now over here, I had to change the top one. Okay, and over here I'm changing the bottom one. Top or bottom does not make a difference. That is not what we are concerned with here for these particular problems. What we're concerned with is which fraction or which denominator is smaller. In this case, it happens to be the 2. Over here, it was the 3, and over here, it's the 2. So I'm going to make this 2 match the 4 up here by multiplying it by 2. And again, that's going to give me my new denominator of 4. I'm also going to multiply my numerator by 2, because again, at any time you change one part of a fraction, you have to change the other part by the same thing. It's going to give me 2/4. And again, 1/2 and 2/4 are equivalent fractions. And again, if you want to put that in maybe a little bit simpler perspective than the decimals or the percentages I did with the previous problem, half of 4 is 2. So if you want to think about it that way, that might be an easier way to kind of contextualize the concept of equivalent fractions. Now, this one already has a 4, so again, I'm just going to bring this over. I'm not going to do anything with it because it already has a denominator 4. And again, I'm just going to subtract these like they're asking and get my answer of 1/4. So you note in both cases, regardless of whether we were dealing with the changing the top denominator or the bottom one, we still use the same methodology. Now, keep in mind, we won't always be using 2. I just wrote down these 2 problems randomly. It happened that the common number to multiply by was 2. That will not always be the case. Theoretically, you can get anything from 2 to 2 million to 2 trillion, whatever. In this case, just happened to work out to be 2. But again, theoretically, you can get any number. Now, this will not work for all of them, I'm afraid. In some cases, you're going to have to change both. And that's going to bring me down to these next 2 problems here. I'm going to start with my adding one to the left here. Now, you may know that 4 cannot be multiplied to get to 5, and 5 cannot be multiplied to get to 4. Well, that's not entirely true. You can multiply 4 to get to 5 and 5 to get to 4, but it's going to be very messy. This method is much easier than dealing with that. So in this particular case, what I'm going to do is I'm going to multiply my denominators by each other. Now, you might be asking, Tim, why are you doing that? Well, multiplying and adding as well have what's called the commutative and associative property. And what those 2 properties are is, if you were to change the order of your adding or multiplying problem, as long as you kept the numbers the same, your answer will be the same. So, if I multiply 5 times 4, I get 20. If I multiply 4 times 5, I still get 20. So even though I changed the order, I flip-flop the order of my numbers, my answer stayed the same. And we will deal more with the commutative and associative property down the line. For our purposes here, though, you just got to know that, again, the opposite, even though I flipped the numbers, I came up with the same denominator. Now, as with the 4, I have to change my numerators as well. So since I multiplied this by 4, I also have to multiply this by 4. It's going to give me 8. Since I multiplied this 4 by 5, I got to multiply this 1 by 5, and that's going to give me 5. And then I'm just going to add those like normal problems. So 8 plus 5, that's going to give me 13 over 20, and that is my answer. So I'm going to go over here and show us another example. Here we have a subtracting problem. You have 7/9 minus 1/5. So again, I'm going to multiply them by the opposite denominators to get my new denominator, my common denominator of 45. But again, if I multiply one part of a fraction, I have to multiply the other part by the same thing. So I'm going to multiply this 7 by 5 as well to get my new fraction of 35 over 45. And I'll multiply this numerator by 9 to get my new fraction of 9 over 45. Now again, just to review, 35 over 45 and 7 over 9 are equivalent fractions. They have the same value. And again, that works out because I multiplied both parts of this fraction by 5, the same number. Same thing down here. 9/45 or 9 over 45 is equivalent to 1/5 or 1 over 5. And again, that's because I multiplied both of these by 9. Now I can subtract them. I'm going to get 26 over 45. I believe that is as low as that fraction can go. I don't think it can be reduced. If I'm wrong, feel free to comment, whether it be in the class stream or in the YouTube video, or just shoot me a text or an email, let me know, but I'm pretty sure that that can't be reduced. Now, normally, you wouldn't get numbers this big. Again, I just picked these 2 numbers randomly because I knew they would work. More often than not, if you get numbers this big, they will be able to be reduced. You notice many of my other problems here, the numbers were a little bit smaller, easier to work with. But in some cases, you may get numbers that are a little bit larger, so don't panic. It happens. It's just not common. Now, as I stated before, there's a certain method that will work for all fractions with uncommon or unlike denominators, and that's what we just went over here. This method will work for all problems like this. Okay. Now, just to show what I'm talking about, I'm going to go back up to this problem here. We did this kind of the shortcut way, and we came with an answer of 5, 6. So let's say I decide to use the same method I used down here. So instead of multiplying this by 2 and 2 to get 4, 6, and not changing this at all, I'm going to multiply these denominators by each other. So I'll multiply these both by 6, and these both by 3. Now the math itself I'm going to do kind of quick just to get to my point here. My new top fraction is going to be 12 over 18, and my new bottom fraction is going to be 3 over 18. So you can see I used, again, the similar method to what I did down here, where I changed both fractions by multiplying them by each other. Add these. 12 and 3 is 15 over 18. Now again, you might be saying, hey Tim, those answers don't match. How does that work? Well, that's because this is not the simplest form of that fraction. I can reduce this because both 15 and 8 can be divided by 3. Okay. So if you divide 15 by 3, you're going to get 5. If you divide 18 by 3, you're going to get 6. So you notice, even though I used a different method, I ended up with the same answer. In this case, it happened to be 5, 6. So as you can see, this method here does work on other fraction problems too. This method is just shorter, less steps. You only have to change one fraction, and there's no reducing at all. This one here had to change both fractions and had to reduce, so it had a few extra steps. I always say the more math you have to do, the more likely you are to make a mistake. So the less steps you do, the easier and quicker things will be. However, some people do like the idea of only having to worry about one rule. And if that is the case for you, if you want to keep things simple, this rule will work for all of them, as you can see up here. So if you want to remember any method at all, this is the one to go with. Again, using it all the time may have you end up doing more work, but again, it is an easier method because it's just the one. It works for everything, whereas this does not work for all of them. Now, there are other potential shortcut ways as well, not just this. I'm going to go down here to show you that method here. So, this problem here, we have 1/4 and 3/10. So I'm going to use the same method I just used to get my answer. I'm going to multiply both of these by 10 and both of these by 4. And that is going to give me 10 over 40 and 12 over 40. Now, when I add those, that's going to give me 22 over 40. Both of those can be divided by 2, so I'm going to reduce that. And I'm going to get my answer of 11 over 20. So that is the answer to this problem. So 1/4 plus 3/10 is equal to 11 over 20. Again, with this particular problem, however, there is a easier method to get your answer. And I'm going to show you that right over here. So you see, we have an identical problem. We have 1/4 plus 3/10. Now, again, you can multiply them by the opposite denominator. That's perfectly acceptable. And again, that may be easier for some people because, again, it's only one rule to remember. However, in some cases, such as this one, there is a smaller common denominator that we can use. In this case, that smaller common denominator happens to be 20. So, if I multiply 4 times 5, and I multiply 10 times 2, I'm going to get answers of 20. So as you can see, I did not multiply them by each other. I multiplied them by a smaller number. However, I still got a common denominator. And the rule still applies. Since I multiplied that by 4 or 5, I got to multiply this by 5. Since I multiplied this by 2, I have to multiply that 3 by 2 to get 6. I'm going to add them, and you will note that I got the same answer. there were fewer steps. Actually, there was one less step. I did not have to reduce. Again, this does not work for all of them. Okay, as you can see, it would not work for this one. In this case, the smallest one is 20. It did not work for this one. In this case, the smallest one was 45. However, the smallest denominator here was 20. So instead of doing this over here, which ended up giving me an extra step of reducing, I can use this method here. But once again, this does not work for all of them. So if you're trying to keep things simple, if you wanted to say, hey, I want to remember one rule and one rule only, which is also good for math, this here is the quickest way, and this is the way that will work for all fractions that have different denominators when you're adding or subtracting. Now, the last thing I'm going to show you is going to deal with mixed numbers. So I'm going to flip the page here, and I have two other problems. In this case, however, they also have mixed numbers. So here I have 2 1/8 plus 1 2/5. Hope you can read that. I know my handwriting isn't the best. So even though I have whole numbers here, the method doesn't change. Okay, we're kind of combining what we learned in the previous slide with what we have here. So here, I have to multiply these two fractions by each other. So I'm going to multiply that by 5, and that by 8. Okay, I'm going to stick with this method even if it doesn't give me the shortest route, only because, again, I'm trying to be kind of consistent. And that's another thing that speaks a lot to math. Math, unfortunately, the easiest way to get better at things is to practice them over and over and over again. That goes with pretty much anything you're going to do, especially some of the building blocks, like fractions, like times tables, like dividing, like adding, like subtracting. I can show you 1,000 ways to do it, but until you start doing it yourself and start practicing, that's the easiest way to get it down. And oftentimes with math comes consistency. So in this case, it might help in the same vein to use the same method in order to stay consistent. But anyway, back to the actual problem. This is going to give me 5 over 40. This is going to give me 16 over 40. And add those two up. It's going to give me 21 over 40. And then I'm just going to add my two whole numbers. It's going to be 3. So the answer to this problem is 3 and 21 over 40. Again, I'm pretty sure that can't be reduced any further down. If I'm mistaken for whatever reason, again, just let me know, but I'm like fairly certain that that's as low as I can go. But you notice the whole number part didn't change. I just added 2 plus 1 to get 3. Again, a bulk of the work was right here. And just to finish things off, I'm going to do a similar problem, but here it's going to have subtraction. Oh, sorry. It's supposed to have subtraction. Now it's subtraction. Okay. So I'm going to, again, multiply by my opposite denominators. It's going to give me a common denominator. In this case, it happens to be 14. Now, instead of adding, though, I'm going to subtract. 7 minus 4 is 3. 10 minus 3 is 7. And that gives me my answer of 7 and 3 over 14. So, again, these two answers look a little odd. Normally, you probably wouldn't get answers that odd, especially this guy here. But it does happen. And in either case, I can't reduce or do anything, so there's really not a whole lot here. So that has been a lesson on how to add and subtract fractions with different denominators. Thank you for listening. Again, if you have any questions, comments, or concerns, you can comment in the YouTube video. You can send me an email, or you can also link down in my Google Classroom. And I will see you for the next lesson.